Hi, Frank. Thank you so much for coming to the Founder Talk. How's it going?
Great. Nice to be here.
Thank you so much for coming. Let's give an introduction to yourself and after, please go straight to pitch.
I'm Frank Hernandez. I'm the CSO of Theralia. I'm a microbiologist by training, but I've been interested in the biorecognition properties of different molecules. And when I mean biorecognition is how a molecule can interact with another and how you can use this to develop biosensors or therapies. I've been interested in oligonucleotides and molecules that I find them fascinating. And I have been developed my scientific career, developing novel oligonucleotide strategies for diagnosis and therapeutics. Okay, so here today I would like to let you know a little bit about Teralia, which is a company that want to revolutionize how the therapy of treating bacteria is being today. We have developed a very fascinating system, but I would like to start with the core technology, what we are doing and why we believe that this is important. So here in blue, you can see a nuclease. A nuclease is an enzyme that can degrade um, oligonucleotides. And these nucleases are located or are associated with diseases. Our job is try to design a specific oligonucleotides that can target in a very sensitive and specific manner those nucleases that we associate with disease. Today, I will tell you about one important problem that is antimicrobial resistance. I'm not going to go into details because I hope that the awareness about this big problem is there. But what I want to tell you is that there are six pathogens that are very important regarding the clinical pathology. And one of them is Staphylococcus aureus, right? And this for in this presentation, I will let you know how we are trying to develop new technologies for that. But before going into the specifics of the technology, let me show you this graph that is a prediction about how antimicrobial resistance is going to impact in the humanity in 2050. And here you can say that is estimated around 10 millions of cases of antimicrobial resistance, which is going to go even higher than cancer cases, but this time. So obviously, there is a clear need for new classes of antibiotics that can really kill and have a defense provide us with a defense against all these pathogens. So during long time and trying to find new antibiotics, um, so many new kind of molecules have been postulated as new antibiotics. And actually, in Terralia, we believe that the problem is that the problem about antimicrobial resistance is not that the lack of antibiotics. There are a lot of molecules that can kill bacteria in a very efficient way. The big problem is that these molecules are also very toxic for the patient. So they are restrictive or they are not used. So one of the great example of this kind of molecules is nucleoside analogues that they are used normally in cancer or viral infections. But obviously, we all know about how devastating are the side effects of chemotherapeutics. So to cure bacterial infection with nucleoside analogs in the way that they are formulated today is very difficult, and the benefit for the patient is questionable. However, if we find a way to formulate nucleoside analogs in a way that only go to the site of the infection, these molecules will be a valuable tool against antimicrobial resistance. And like I mentioned before, today we are focusing on Staph aureus as a proof of concept. And I just want to let you know that the market for Staphylococcus aureus right now is around $4 billion, dollars, and it's expected that is going to be higher in the future based on this phenomenon of antimicrobial resistance. So coming back to the technology, at the end, what we're trying to do is to identify, in this case, that we want to identify one bacteria that is Staph aureus. We associate one specific nuclease that is derived from this bacteria with the presence of this pathogen. And what we want to do is to identify an oligonucleotide that can be cleaved by the nuclease that is associated with the bacteria. But at the same time, this oligonucleotide has to be resistant to any human nuclease or any other nuclease derived from bacteria. And that's why, with this in mind, we have in Theralia, we developed a project that we call TUCAN. It stands for Therapeutic Oligonucleotides Activated by those nucleases. And obviously, the our TUCAN looks more like this one, which is a molecule that is an oligonucleotide that has 7 mer. But in our construct, something important is that is something similar like an Lego system in which we have three modalities or three moieties. So one moiety provides resistance to any other nuclease that we don't want to target. There is a region that recognizes Staphylococcus aureus nucleases, and there is one nuclease that is those nucleoside analogues that we use as a therapeutic drug. So just to give you an idea of how this is going to work in the future, or uh, here I have a small video that represents what we are doing. Toucan products will be indicated for local infections. And these local infections, at the beginning, the bacteria start to create this abscess. The bacteria start to grow and at the same time produce the nucleases that are the biomarkers. Toucans will be injected systemically and they will be resistant to any human nuclease, but will be specific in this case for Staph aureus. They will release the nucleoside analog that will be able to kill the bacteria. And in that way is how Theralia is planning to cure infections in future in humans. So this is how we envision the technology, but right now I can tell you that this is we have proved that this is possible. We have our first proof of concept in mice that were infected with the bacteria that is Staph aureus, and here in this picture, you can see that after we treat mice that were infected with Staph aureus, we're able to cure the infection 100%. And when you compare with the placebo, you can see the formation of the infection there and everything. And when you treat only with the nucleoside, remember that this naked and can affect and create so many side effects. We also saw the infection, so indicating that our toucan was able to circulate by tail vein injection and go to the place of the infection and kill the bacteria. In addition to this, we have a patent that covers our technology that now is at the national phase in Europe and USA. And also we have an FTO that demonstrate that we don't have any kind of problem regarding the use of intellectual property from other people. All these have been published in the Journal of Control Release. So at the end, obviously there are some competition for us. We believe that the main competitors in the market are the nucleoside analogs that are already there. They are being used in the market. But our advantage here is that we can provide a drug delivery system for those nucleosides and limit the action at the local infections. But also, we believe that more like in a technical way, our competitors are approaches similar or like antibody drug conjugates, which they have the same modality. They want to target specific regions that are infected and release a drug. However, our technology Duken has several advantages over traditional antibody drug conjugates because, like I mentioned before, being an a catalytic reaction over biomarker is that nuclease. One nuclease can catalyze thousands of our toucans. And when you compare this with antibodies that conjugate, they can transport only one or two molecules per antibody. So obviously, our efficiency here is higher than any antibody drug conjugate. And also, there are a lot of, let's say, advantages regarding the production. Our oligonucleotide is chemically synthesized, and antibodies, they require cells of animals. So regarding our strategy, our idea is to complete our preclinical phase, the non-clinical, and start clinical trial one in the next 2 years. For that, we are trying to find an investment of around 4 millions, 1 million, and then three. Here you can see more or less what are the idea of how we're going to spend this money. And I would like to end up with this the most important aspect of Terraria, that is the team. We have a team of very compromised scientists with expertise in clinical microbiology, oligonucleotide technology, cancer. Also, we have an advisor that is helping us out with the regulation and PKPD studies. And recently, we have a CEO that is going to take care of all the business and management of investors. And with all of this, we believe that we have a great company that is attacking a big challenge that we have today, that such as antimicrobial resistance. And with this, I just want to thank you for your time, and I'm happy to answer any question.
Thank you, Frank. What's your time to market?
Well, we believe that if everything is as planned in 2031, tucanemase could be available in the U.S. market, and it's U.S. market because based on the drug that we are using in this first product, that is the tucanemase, the which is fluoxuridine. This drug has been approved in states before, and we believe that taking advantage of whatever has been done regarding this drug, we have the biggest chance to accelerate the process to 2031.
In terms of approvals, the first market that you are going to ask for approval is the US.
Yes, that's right. And the reason is just what I mentioned. This first antibiotic, first product concept that we have developed is targeting Esaurus, and the drug that we use is fluoxuridine. And fluoxuridine being approved in the States by the FDA, they have all the toxicity and all the clinical trials that were required for this. So we can try to understand how they did it, and try to design the best experiment that can compare to the toxicity of that molecule. Also, keeping in mind that our molecule is going to be a prodrug system, we will need to do some additional work. But obviously, states at this moment for Tucan MRSA is the market that offers the shorter path for.
What about Europe?
And obviously, at the same time, we're gonna work with Europe. But our idea is this: as long as we have a clear path of this, we have a new chemical class of antibiotic. When you are the first one in anything, it's good to have a reference, right? So everything that we're gonna do in the States with FDA regarding how we can get into the market one of these products will be very useful for any other market or any other product that we can develop. So we want to attack the faster way to get to the market, but Europe will be at the same in parallel, right? But after 1 year after.
For this round, if I'm right, is 4 million. Where this round is bringing you, and how many rounds do you believe you have after this to reach the
Okay,
market?
so this is the round eight that we're planning. And with this money, we're going to get to the clinical trial 1A. So we're going to complete all the preclinical and preclinical work, very thorough dossier with PK, PD, toxicity. And with this one, we can start to filing our IND and start with the first in human studies. And that's how we believe that with this 4 million, we can get there. We will have an extra round to try to go to the complete phase 1B, and our goal is in the series B, that is going to be, it's very difficult to predict right now, but will be of 8 to 20 millions, will be to complete the phase 2A. And at that point, it's our goal to get there. And at that moment, we will need to find big pharma that is interested in our asset. So we're not going to wait until there to look for the pharma, obviously. But I think that this is our plan. I mean, we want to get until there and try to find someone that is going to be engaged on helping us with the co-development, or we can license our technology to complete phase three commercialization and everything, because obviously we don't have the capability to get to the market alone.
In 20 seconds, the best elevator pitch you can to convince investors to invest in your startup.
So we are Teralia. We are developing a very innovative strategy because we believe that we can treat bacterial infections in a better way. And by better way, we mean that we can have high efficacy, but we can reduce toxicity and make all these treatments not only effective but very safe for all patients out there. Resistance is a big issue, and we believe that we can help to combat in this challenge that we have right now.
Frank, thank you so much for taking part in the Founder Talk. Thank you.
Thank you. Thank you very much for having me, and have a great day.
You too. My pleasure.